In this practical, we will try with some simple simulation and estimate heritability for simulated data. So you need a desktop or laptop and are installed in your machine, and also you need a library mass and Excel file. And course material for this practical can be downloaded from this website that include R code and some Excel file. So I can so if you when you go to this directory, I will show you. Yeah, then you can, if you go the address, then you can find some link under the title population analysis using statistical genetic tool. Then you can click, then the materials can be downloaded to your machine. So I already downloaded. Then I will show where is, yeah. So I use Mac, so the system looks like this, but probably Windows or other platform also similar. Or you can use probably Party or other Cwin or any other application. So I already made this where this folder is. So this is where I downloaded and unzip the file. Actually not. Sorry. Yeah, so this one. This folder I downloaded the file and unzip. Then you can find some R code. So in this practical we will use this code and also these two codes. So make sure that you have this R code in your folder. Okay. Then now we can ready to go. We are ready to go. So first practical using the VG that represent the genetic variance, and SIM is a simulation. So this is a simple simulation for genetic variance and residual variance, and some of them is phenotypic variance. So first question is what is phenotypic variance? Before going this practical, we can have a look what does the code looks like. So we can have a look. So the code name is VZ. Yeah, so library mass is for multivariate normal distribution simulations that used in somewhere here. I will explain soon. Then here the simulation number of record is 10,000. Then number of trait is 1 at the moment. Then the mu is the mean that I show in the lecture, that normal distribution, then the middle of the distribution is actually mean, right? That's mu. Then it all set as a 0, assuming the variables are mean centered. Then this is a true simulated value that genetic variance is set as 5 and residual variance set as 12. Then this is how to simulate genetic values. So I give a name as a GV, genetic value. So this is our function, that's normal distribution, as a Tn, the number of records. So I will simulate 10,000 record as a mean 0, that is here, mu 0. Then variance G is 5. So in R code, the function R norm requires standard deviation rather than variance. So this will give 10,000 genetic values. And exactly same function, then we will also simulate residual variance that I assign as EV. So same number of record and the mean is 0 as well. And the variance is come from the residual variance here. That's 12. Okay. Then according to the equation P equals G plus E, so here I assign as YV, that's phenotypic value, and GV is genetic value, and EV is a residual value. So this is actually phenotypes. So from these phenotypes, you can work out the phenotypic variance, right? So also you know the genetic value as well as the variance, also residual value and residual variance. So it is straightforward to get the phenotypic variance and genetic variance, therefore heritability. Okay, so we can run it using R. So this is the same folder as here. Then I will run R. Then so in R function, the source is one of the make the code run. So I will, so that's VZ, right? So we call VZ, then it run. So from the one replicate based on this simulation code, that is this one, the phenotypic variance is around 16.9 and genetic variance is around 5 and heritability is around 0.291, right? So let's have a look at what is the question. So sorry, yeah. So what is phenotypic variance? So we already saw the phenotypic variance is around 16.9, right? Easy. That's easy. Just, then what is the genetic variance? There is genetic variance here, 4.95. And what is, so we can see, so what is highest value uh, for the genetic value? So what is the highest value for the genetic value? So we can see the maximum and minimum value. Also, first maybe we may have looked at histogram. So we can draw histogram from the genetic value. Then something like this, right? So the maximum value is around 9 and minimum value is around -9, right? So this is a normally distributed mean as 0. That is what we simulated. Also, genetic variance we simulated as 5. So this around 5 is one standard deviation, as I show in the lecture, right? Then this is a distribution of the value. Okay, so the answer is maximum value of genetic variance is 7.8 and minimum value of genetic variance is -9. Okay, and next question, yeah, we did. Then what is expected heritability and what is observed heritability? So from the simulation, we assigned as true simulated value for the genetic variance as 5, right? Then residual variance is 12. So what is expectation? That is genetic variance divided by genetic variance plus residual variance, right? So the expected heritability is 0.294, okay? Then what is observed heritability? That is 0.291. right? They are very similar. Okay. Then the question, why the expected heritability and observed heritability is slightly different. This is because we use the stochastic simulation. That's why there is a sampling error that depending on the number of record. Okay, so if this record is smaller, then the difference is larger. If this number is large and goes to infinity, then expectation and observation is closer and closer. Okay,